We've all done it, gazing up at the night sky, lost in the stars, and wondering if we're truly alone in the vast expanse of the universe. The dark sky above us is an awe-inspiring and humbling canvas, filled with millions of stars and the endless possibility of what might be out there. But beyond that, beyond the twinkling dots of distant stars, what's really out there? As we stand here on Earth, we know that we share this planet with millions of species of life, all living under the same sky. But could there be another place, somewhere else in the universe, where life thrives in the same way it does here? Is it possible that somewhere, far beyond our reach, another civilization is gazing up at the stars, just like us, wondering the same question? This is the question that drives the search for planets that exist outside of our solar system. These distant worlds hold the key to one of humanity's most profound quests. Could we ever live on another planet? And is there life out there beyond Earth? Today, we'll explore the fascinating world of exoplanet discovery, the search for alien life, and the incredible journey that might one day take us beyond the confines of our home planet. The search for exoplanets didn't just begin in the modern age, but it has a long history of speculation and wonder. For centuries, the idea that planets orbiting other stars could exist was considered more of a philosophical or speculative question. After all, how could we ever prove that these other worlds were real? The Greek philosophers and ancient astronomers were among the first to contemplate the idea of distant planets. Though they didn't have the technology to confirm it, fast forward to the 20th century, when space exploration finally became a reality. The first step in discovering exoplanets was finding the right tools and technology. In the 1990s, astronomers Michel Mayor and Didier Queloz made a groundbreaking discovery. Using a technique called radial velocity, they detected the subtle gravitational influence of an orbiting planet on its star. This discovery, which happened in 1995, marked the first confirmation of an exoplanet orbiting a Sun-like star. It was a breakthrough that confirmed what had previously been a theory and began a new chapter in the story of space exploration. Since then, astronomers have developed new and increasingly sophisticated methods for detecting exoplanets. One of the most important advancements has been the transit method, which was primarily pioneered by NASA's Kepler space telescope. The idea behind this method is relatively simple. When a planet passes in front of its star, it blocks a tiny fraction of the star's light. By measuring the drop in brightness, astronomers can determine the planet's size, orbit, and distance from its star, using the transit method. Kepler identified over 2,600 exoplanets during its mission, many of which are in the habitable zone, the region around a star where conditions could support liquid water. Water is a key ingredient for life as we know it. And finding planets in the habitable zone of their stars is a big step in the search for life. Beyond Earth, in addition to the transit method, astronomers also use the radial velocity method. This technique measures the gravitational pull that a planet exerts on its star. Even though the effect is incredibly small, it can be detected through careful observation. This method has been responsible for identifying a significant number of exoplanets. The discoveries don't stop with just finding exoplanets. The next question is, are these planets capable of supporting life? For a planet to be considered habitable, it needs to meet several key criteria. The first and most obvious factor is the habitable zone of the star it orbits. The habitable zone is often referred to as the Goldilocks zone, not too hot and not too cold, but just right. A planet in this zone has the potential for liquid water, a fundamental ingredient for life as we know it. But location alone isn't enough. A habitable planet also needs to be of the right size and composition. Planets that are too large, like Jupiter, are gas giants, and while they may be fascinating in their own right, they are not likely to support life. Earth-like planets, which are rocky and have a size similar to our own, are much more likely to support life. The next critical factor is a planet's atmosphere. A thick atmosphere can protect life from harmful radiation, regulate temperatures, and provide the essential components necessary for sustaining life like oxygen and carbon dioxide. Without an atmosphere, a planet's surface would be exposed to dangerous levels of radiation from its star, making it a poor candidate for life. Beyond just finding planets that are capable of supporting life, astronomers are also looking for direct signs of alien life. This is where the search for biosignatures comes in. A biosignature is any substance or phenomenon that provides scientific evidence of past or present life. The idea is that we could detect these biosignatures in the atmospheres of exoplanets. The James Webb Space Telescope, JWST, launched in 2021, is designed to look for biosignatures in exoplanet atmospheres in greater detail than ever before. By studying the light that passes through a planet's atmosphere, JWST could potentially detect key chemicals like oxygen, methane, and carbon dioxide, which are associated with life. This opens up the possibility of detecting microbial life on distant planets, which would completely change our understanding of biology and the universe. The search for life beyond Earth is one of the most profound and exciting questions humanity can ask. Every time we discover a new exoplanet, it feels like we're taking another step closer to answering this question. But even though we're making incredible strides, the truth is, we're still only beginning to understand the universe and its many mysteries. For me, the search for exoplanets and alien life is both thrilling and humbling. It's thrilling because we're on the brink of discovering something truly monumental, something that could change the course of history. But it's also humbling because we're reminded of how much we don't yet know. The universe is vast, and we're just one small part of it. To me, that's one of the most exciting aspects of this search. Keeps us humble, curious, and driven to keep exploring. The search for exoplanets and alien life is more than just a scientific endeavor. It's a journey that spans centuries of curiosity, technology, and discovery. While we've made incredible progress, the search is far from over. With new technologies like the James Webb Space Telescope, we're poised to learn even more in the coming years. Whether we find evidence of alien life or not, the quest to understand the universe is a testament to human ingenuity and our unyielding desire to explore the unknown as we continue to search the stars. We're reminded that we are, in a sense, explorers on a grand scale, driven by the same curiosity that has always fueled humanity's greatest achievements. The road ahead is long, and who knows what we'll find when we look up at the stars next. Stay tuned, and make sure to subscribe as we continue our journey into the cosmos. In our next episode, we'll dive deeper into the methods scientists use to detect these distant worlds and what they're looking for when they search for habitable planets. Don't miss it. Don't miss it. Imagine this. It's 1995, and astronomers are gathered at their observatories, peering into the depths of space, looking for something that no one had ever found before: a planet orbiting another star. After centuries of wondering if other worlds existed, the answer comes not from a theoretical model or mathematical equation, but from actual data. This was the moment when everything changed. The first confirmed exoplanet discovery wasn't just a breakthrough in astronomy. It was a monumental shift in our understanding of the universe. But how did we go from wondering about other worlds to actually finding one? How did astronomers uncover these hidden planets? Let's rewind and explore the story of how exoplanet discovery came to life. It all began in the early 1990s, when astronomers were not looking for planets at all. Instead, they were trying to understand the behavior of pulsars, highly magnetized, rotating neutron stars that emit beams of electromagnetic radiation. But in 1992, something unusual happened. Two astronomers, Alexander Volchin and Dale Frail, discovered something remarkable while studying the pulsar PSRB 1257 plus 12. They found not one, but 3 planets orbiting the pulsar planets that were completely unlike any we had in our solar system. These were the first exoplanets ever discovered. However, this discovery raised more questions than answers. These planets were orbiting a pulsar type of star that's extremely hostile to life. So it didn't directly imply that planets could exist around sun-like stars. Most astronomers at the time believed that planets around stars like our Sun might be exceedingly rare. And so this discovery didn't necessarily change our view on the possibility of other habitable worlds. That all changed in 1995, in my opinion. The excitement of 1995 was palpable. The discovery of these pulsar planets was groundbreaking, but it was the discovery of the first sun-like exoplanet that felt like the true turning point. It meant that, contrary to what many had believed, planets could indeed exist around stars like our sun stars that might one day be home to life, or at least harbor the conditions for life. The dream of finding Earth-like planets began to feel more like a possibility, and not just a far-off fantasy. In 1995, Michel Mayor and Didier Queloz, Swiss astronomers, made a historic breakthrough. They discovered 51 Pegasi b, the first exoplanet to orbit a sun-like star, using a method known as radial velocity. This technique, also referred to as the Doppler method, involves detecting the small, periodic wobble of a star caused by the gravitational pull of an orbiting planet, while the wobble is tiny. It's enough to be measured by precise instruments. What made this discovery even more remarkable was that 51 Pegasi b was a gas giant similar to Jupiter, but it was orbiting incredibly close to its star. Despite its hostile environment, the discovery proved that planets could exist around stars like the Sun. This fundamentally changed our understanding of planet formation and set the stage for further discoveries. The method of radial velocity has since become one of the primary tools for exoplanet discovery. The reason it's so effective is that it can detect planets even if they are too small or too far away to be seen directly. While the method is useful, it has its limitations. It works best for detecting larger planets that orbit closer to their stars. Smaller, more distant planets like Earth are much harder to detect using radial velocity alone. I have always been fascinated by how these astronomers were able to spot a planet by measuring the tiniest of wobbles. It's remarkable to think that such a small movement, almost imperceptible to the naked, could reveal a world previously hidden from us. To me, that's one of the most exciting parts of this discovery. It proves that the universe is full of mysteries, just waiting for us to uncover. And sometimes, the smallest clues lead to the greatest discoveries. While the discovery of 51 Pegasi b was a monumental achievement, it wasn't just about finding one planet. It was about proving that there were other worlds out there waiting to be found. In the years following the discovery, astronomers began developing more advanced techniques to search for exoplanets. One of the most important advancements was transit photometry. The transit method involves measuring the dip in a star's light as a planet passes in front of it. This technique provides more data than the radial velocity method because it allows astronomers to directly measure a planet's size, its orbit, and even its atmospheric composition. If the planet has an atmosphere, this method was a game changer, as it enabled astronomers to detect not just any exoplanets, but Earth-sized planets in the habitable zone areas around stars where liquid water could exist. The Kepler Space Telescope, launched in 2009, was the tool that really propelled the search for exoplanets forward. Kepler's mission was simple but ambitious. It would observe a small section of the sky for over 4 years, measuring the brightness of over 150,000 stars. By detecting the dimming of stars as planets passed in front of them, Kepler confirmed the existence of over 2,600 exoplanets, many of which were in the habitable zone. These findings made it clear that there were far more planets out there than we had ever imagined. For me, Kepler's mission was a watershed moment in exoplanet discovery. It wasn't just about finding more planets. It was about realizing the sheer number of planets that could exist in our galaxy alone. Kepler's findings showed us that we're just one of potentially billions of planets in the Milky Way. And there are many more yet to be discovered. It's humbling, but also deeply exciting to think that we might be living in a galaxy teeming with other worlds, some of which could be just like ours. The birth of exoplanet discovery has completely changed our view of the universe. What was once a theoretical idea with a handful of speculations and hypotheses has now become a flourishing field of study, with thousands of confirmed planets and even more waiting to be discovered. The search for exoplanets is far from over, and with each new discovery, we come closer to answering one of humanity's most profound questions. Are we alone in the universe? With the help of advanced technologies like the James Webb Space Telescope and ongoing missions like TESS, we'll continue to search for exoplanets in the hope that one day we'll find a world that could support life, or perhaps a planet that could one day be our new home, as we stand on the shoulders of giants like Mare and Queloz. We realize that the journey to discovering new worlds is just beginning. And as we look forward to the future of space exploration, one thing is certain: the universe is full of surprises. If you've enjoyed this exploration of how we first discovered exoplanets, be sure to hit the subscribe button and stay tuned. In our next episode, we'll dive deeper into the technology that allows us to find these distant worlds and how we analyze their potential for supporting life. Don't miss it. Don't miss it. Imagine this. You're an astronomer standing at the edge of the universe, looking out at the vastness of space. The stars before you are not just points of light. They could be harboring planets, entire worlds waiting to be discovered. But how do you peer beyond the horizon of our solar system to find these distant planets? How do you unveil the secrets of a universe filled with countless stars, each potentially hosting a world of its own? Well, the answer lies in technology-advanced tools, sophisticated telescopes, and innovative methods that allow us to explore the distant reaches of space. Today, we'll uncover how these technologies have made the search for exoplanets a reality. We'll look at the cutting-edge equipment that allows us to detect planets that are light years away, and how scientists use this technology to study these distant worlds in ways we never thought possible. The search for exoplanets might seem like an impossible task. After all, planets are tiny compared to the stars they orbit. How do you spot a planet when it's so far away and so small? The answer lies in the technology that allows astronomers to see what's invisible to the naked eye. One of the most groundbreaking tools in the hunt for exoplanets is the Kepler Space Telescope. Launched by NASA in 2009, Kepler was designed to monitor a small region of the sky for several years, looking for the telltale signs of exoplanets. But what was Kepler's secret weapon? The transit method. When a planet passes in front of its host star, it causes a tiny dip in the star's brightness. This is known as a transit. Kepler observed stars constantly, waiting for these small dips in light. Every time it detected a dip, astronomers would analyze the data to determine if it was caused by an exoplanet passing in front of its star. This method allowed Kepler to discover thousands of exoplanets, many of which were in the habitable zone, the region around a star, where liquid water could potentially exist. I find it mind-blowing that with just a tiny dip in brightness, we can learn so much about a distant planet. The fact that we're able to detect planets that are sometimes thousands of light years away, using such a simple method, shows just how far technology has come. It's like we're learning to hear the faintest whispers of a conversation from across the room, or in this case, across the galaxy, in addition to the transit method. Astronomers also rely heavily on the radial velocity method, a technique that was actually instrumental in the first discovery of an exoplanet. This method detects the subtle gravitational wobble of a star caused by an orbiting planet. Here's how it works. When a planet orbits its star, it doesn't just move in a perfect circle. The planet's gravity causes the star to wobble ever so slightly. This wobble is tiny but incredibly important. By measuring the shifts in the star's light, astronomers can calculate the mass of the planet, its orbit, and even its distance from the star. This method works particularly well for detecting larger planets, especially those that are closer to their stars. While the radial velocity method doesn't provide us with direct images of planets, it gives us a wealth of data about their orbits, size, and distance from their stars. The radial velocity method always amazes me. To think that we can measure a star's wobble, just a tiny nudge from a planet millions of miles away. To determine the characteristics of that planet, it feels like we're tapping into the very rhythms of the universe. It's a perfect example of how small, seemingly insignificant movements can reveal hidden truths about distant worlds. But the real game changer came with the advent of direct imaging. While both radial velocity and transit methods work well for detecting planets, they don't give us the complete picture. For that, we need to directly observe the planets themselves. Direct imaging involves capturing an actual picture of an exoplanet. But there's a catch: it's incredibly difficult because the light from the host star is usually much brighter than the light from the planet itself. To get around this, astronomers use coronagraph special instruments that block out the light from the star, allowing them to see the faint light reflected from the exoplanet. This technique has led to some amazing discoveries. For example, astronomers have captured images of young exoplanets' planets that are still forming and glowing brightly. While this method isn't as widely used as the transit or radial velocity methods, it's incredibly valuable for studying young planetary systems and planetary atmospheres. When I see images of exoplanets captured directly, I can't help but feel a sense of wonder. The fact that we can look at a planet light years away and see its features, its glow, its atmosphere, it's a reminder of how much technology can stretch the boundaries of our imagination. It makes the universe feel a little more real and a little less distant. The next major leap in exoplanet discovery comes with the James Webb Space Telescope, JWST. Launched in 2021, JWST is the most advanced telescope ever built for studying exoplanets. It's capable of observing exoplanet atmospheres in infrared light, which means it can study molecular compositions in the atmospheres of distant worlds. This opens up a whole new realm of possibilities. JWST will be able to look for biosignatures of life in the atmosphere of exoplanets. For instance, if an exoplanet has oxygen, methane, or carbon dioxide in its atmosphere, it could suggest that life, at least in some form, might exist there. JWST's ability to directly study exoplanet atmospheres will provide us with more information than ever before. I'm particularly excited about the James Webb Space Telescope because it holds the potential to answer the most profound question of all: is there life beyond Earth? If JWST detects biosignatures in the atmosphere of an exoplanet, it could be the biggest discovery in human history. The idea that we might find evidence of life out there is both exhilarating and humbling. It's the ultimate search, and it feels like we're on the verge of a historic breakthrough. The search for exoplanets is a thrilling journey, and it's one that has only just begun. The technology that has been developed to detect and study these distant worlds is nothing short of extraordinary. With tools like Kepler, TESS, JWST, and direct imaging, we've made incredible strides in understanding the cosmos. But as we continue to push the boundaries of technology, one thing is clear: we've only just scratched the surface as we look to the future. The potential to find habitable exoplanets and even signs of alien life seems more possible than ever. The tools and techniques we've developed have opened the door to a new era in space exploration. And while we don't yet have all the answers, the search continues, driven by human curiosity and the unyielding desire to understand the universe. If you're as fascinated as I am by the possibilities of what we could discover in the near future, Don't forget to like and subscribe. In our next episode, we'll take a deep dive into the factors that make a planet habitable and explore the next steps in humanity's journey towards space colonization. Stay tuned, there's much more to discover. We've discovered thousands of exoplanets, but the real question is, could any of these planets actually support life? What makes a planet habitable? It's not just about location, size, or proximity to a star. It's a combination of factors that work together to create the conditions necessary for life to thrive. In this session, we're going to explore the critical ingredients that make a planet habitable and why some planets in the habitable zone could still be hostile to life. As we look into these factors, imagine, could one of these far-off worlds one day become our second home? Let's take a closer look at what it takes to support life beyond Earth. When scientists search for exoplanets that might support life, they look for several key characteristics. These characteristics, or criteria, what determine whether a planet is capable of maintaining the conditions necessary for life as we know it. Here are the main factors that play a role in determining a planet's habitability. Location in the habitable zone. One of the first things scientists look for in an exoplanet is its location in the habitable zone, the region around a star where conditions could support liquid water. This area is often referred to as the Goldilocks zone because it's not too hot and it's not too cold, but just right for life. A planet in this zone has the potential to host liquid water on its surface, a critical ingredient for life as we know it. However, the habitable zone is not a one-size-fits-all concept. It depends on the size and type of the star. For example, M-dwarfs, red dwarf stars, which are smaller and cooler than our Sun, have much smaller habitable zones. Planets orbiting. These stars would need to be much closer to the star than Earth is to the Sun to be in the habitable zone. Conversely, larger stars, like type stars, have much wider habitable zones. But these stars burn through their fuel much faster, meaning any planet in that zone would have a much shorter window to develop and sustain life. When I think about the Goldilocks zone, I can't help but feel that it's the universe's way of giving us a chance. It's almost as if nature has a specific recipe for life, a mix of the right temperature, the right distance from a star, and just the right conditions for life to take root. It's reassuring to think that maybe, just maybe, there are other planets out there that are in that perfect sweet spot. But, as we'll see, there's more to habitability than just location. Planet size and composition. Another crucial factor in determining whether a planet is habitable is its size and composition. Planets that are too large, like Jupiter or Saturn, are typically gas giants and are unlikely to support life in the same way Earth does. These planets have massive atmospheres, made mostly of hydrogen and helium, with no solid surface to live on. On the other hand, planets that are too small may not be able to hold on to a thick enough atmosphere to support life. A planet like Mars, while located in the habitable zone, is too small and has too thin of an atmosphere to support life in the way Earth does. Smaller planets also tend to cool down faster, which could make it difficult for life to develop. For a planet to be habitable, it needs to be rocky and have a surface that could support liquid water. Rocky planets, like Earth, are made of materials that allow them to form a solid surface, which is essential for the development of life. The size of the planet matters too. If a planet is too large, it may develop a strong gravitational pull that could trap toxic gases in its atmosphere, making it inhospitable. If it's too small, it might not have the necessary elements for life to thrive. It's amazing to think that a planet's size and composition could be the deciding factor between life and no life. Earth is the perfect size, large enough to have an atmosphere and an active geology, but small enough to avoid the issues faced by gas giants. I sometimes wonder how many other rocky planets like Earth are out there, just waiting to be discovered. The search for them feels like looking for a needle in a cosmic haystack. But every discovery brings us closer to finding that needle. Atmosphere and climate. The atmosphere of a planet plays a huge role in its ability to support life. The atmosphere acts as a protective shield, filtering out harmful radiation from its star and helping regulate the planet's temperature. It also contains the gases necessary for life, such as oxygen, carbon dioxide, and nitrogen. A thick atmosphere like Earth's is essential for keeping the planet warm enough to maintain liquid water. The greenhouse effect, a process where certain gases trap heat in the atmosphere, helps maintain the right temperature on Earth. However, too much of a good thing can be dangerous. If a planet's atmosphere contains too much carbon dioxide or methane, it could cause the planet to become too hot, as seen with Venus, which has a runaway greenhouse effect. Scientists are particularly interested in finding planets with atmospheres, similar to Earth's ones that can support life without extreme temperatures. Telescopes like the James Webb Space Telescope, JWST, are capable of analyzing the atmospheres of distant planets by looking at the light that passes through them. By studying this light, scientists can determine what gases are present and whether the planet could support life. I think the atmosphere is one of the most fascinating aspects of planetary habitability. It's incredible to think that the balance of gases in the air can be the difference between a livable planet and one that's hostile to life. It's also a reminder of how fragile life on Earth is. If our atmosphere were just a little different, if we had too much methane or not enough oxygen, our world could be an entirely different place. It's a delicate balance, and that's part of what makes Earth so unique. Magnetic field, another often overlooked factor in a planet's habitability is its magnetic field. Earth's magnetic field acts as a shield, protecting us from harmful solar and cosmic radiation. Without this magnetic protection, our atmosphere could be stripped away by solar winds, and life on Earth would be impossible. Mars, for example, has no global magnetic field, which is part of the reason its atmosphere is so thin and its surface is constantly bombarded by radiation. Scientists have speculated that if Earth didn't have its magnetic field, it might have suffered the same fate as Mars. A strong magnetic field is therefore essential for protecting life from the harsh environment of space. This is one of the factors that scientists will look for when searching for habitable exoplanets. The magnetic field is one of those factors that we don't always think about, but it's so crucial for protecting life. Without it, we would be exposed to radiation that could be deadly. It's like the Earth has its own force field, something that's invisible but absolutely vital for our survival. It makes you realize how lucky we are to have all of these conditions perfectly aligned on our planet. So, what makes a planet habitable? It's a combination of location, size, composition, atmosphere, and magnetic protection. While finding a planet in the habitable zone is the first step, it's just one piece of the puzzle. A truly habitable planet must meet all of these criteria: the right size, the right atmosphere, and the right conditions to protect life as we continue our search for habitable exoplanets. These factors will guide us toward discovering the planets that could one day be our new home. But it's not just about finding planets in the habitable zone, it's about understanding the delicate balance of conditions that make life possible. When I think about all of the factors that make a planet habitable, it's awe-inspiring. Earth is the only planet we know that has all of these conditions, and it's easy to take it for granted. But as we continue to search for other habitable planets, I'm reminded that our world is incredibly special. There may be other planets out there that have the same potential, but finding them will take time and perhaps a little luck. And who knows, maybe one day we'll find a new world that we can call home. If you've been fascinated by the idea of finding another Earth, stay tuned. In the next episode, we'll explore the exciting possibility of colonizing exoplanets. What challenges lie ahead, and how humanity could one day leave Earth behind. Don't forget to subscribe, like, and share if you're excited about the future of space exploration. Imagine standing on the surface of a distant planet, gazing out at a strange, alien sky. Perhaps you see two suns in the sky, or a ringed world in the distance. The air is breathable, the temperature is just right, and you're standing on a planet light years away from Earth. It sounds like science fiction, doesn't it? But what if it's not? What if, one day, we could step foot on another world, not just as explorers, but as permanent settlers? The search for exoplanets has brought us closer than ever to answering the question, could we ever live on another planet? In this session, we're going to explore the exciting and often daunting possibility of colonizing exoplanets. From the technological advancements that would be required to the challenges we'd face in adapting to alien worlds. We'll look at what it would take to make life on another planet not just possible, but a reality. Colonizing another planet is a tantalizing dream. But it's not as simple as hopping on a spaceship and landing somewhere. The first major challenge we face is distance. Even the closest exoplanets are still incredibly far away. Take Proxima Centauri b, for example, the nearest potentially habitable exoplanet to Earth, located about 4.24 light-years away. It would take our fastest spacecraft, like NASA's Parker Solar Probe, over 17,000 years to get there. This immense distance presents a major hurdle in the colonization of exoplanets. Current space travel technologies aren't fast enough to make interstellar travel a practical option in the foreseeable future. And it's not just the distance that's the problem. It's the time it would take to get to these worlds. A journey lasting thousands of years is simply not feasible for human colonization. But there are ideas in the works for potential solutions. One possibility is generation. Ship self-sustaining spacecraft that could carry multiple generations of people on their journey to a distant world. These ships would be equipped with all the resources needed to survive over many decades or even centuries, ensuring that future generations would be able to reach the destination. However, these ships would require careful planning. The crew would need to be isolated from the outside world, growing their own food, recycling water, and sustaining themselves over extended periods of time. For now, the idea of generation ships remains theoretical, but it's an intriguing possibility for the future of interstellar travel. The concept of generation ships is something that I find both fascinating and sobering. The idea that future generations would live their entire lives on a ship, knowing that they might never see Earth again, is a powerful reminder of how far we still have to go before we can truly venture beyond the confines of our solar system. I think it speaks to the persistence of the human spirit, our willingness to pursue dreams that seem impossible. Even if those dreams won't be realized in our lifetimes, even if we could somehow overcome the distance barrier, we'd still face the challenge of surviving on another planet. It's not just about finding a planet that could potentially support life, it's about figuring out how to live there. One of the most important considerations is the planet's atmosphere. While planets in the habitable zone may have the right temperature to support liquid water, their atmospheres may not be suitable for human life. Take Mars, for example. While it's located within our solar system and has many Earth-like features, its atmosphere is incredibly thin, made mostly of carbon dioxide with little oxygen. This would make it impossible for humans to survive without life support systems. If we were to colonize a planet, we'd need to create artificial habitats that could supply breathable air, regulate temperature, and provide food and water. We'd likely need to build domes or underground bases to shield ourselves from harsh environmental conditions and radiation from the star. One idea is to create closed-loop ecosystems, environments where waste products are recycled, air and water are filtered, and food is grown in controlled environments. In fact, NASA has already conducted experiments on Earth to simulate life in closed-loop systems, such as the Biosphere 2 project. These experiments have shown that it's possible to create self-sustaining habitats in a controlled environment. But scaling this up for an entire colony is still a major challenge. Living on another planet would require a level of ingenuity and resourcefulness that we can barely comprehend today. But the idea that we could one day create a self-sustaining environment on a foreign world is both awe-inspiring and terrifying. It reminds me of how resilient humanity is, how we've always found ways to adapt, survive, and thrive, even in the harshest conditions. The question is, how far will we go to make this possible? Another major issue we would face is the planet's radiation environment. On Earth, we are protected from dangerous cosmic and solar radiation by our planet's magnetic field and atmosphere. However, many exoplanets, especially those that are further from their stars or orbit stars with high levels of radiation, may not have this protective shield. This poses a major risk for colonists, as prolonged exposure to radiation can cause severe health problems, including cancer and genetic mutations. To combat this, colonists would need to be protected by radiation shielding. This could be achieved by constructing habitats below the surface of the planet, where the soil or rock could provide natural protection. Another possibility is using water or hydrogen-rich materials as radiation shields. Since these substances are effective at blocking harmful radiation, when I think about the challenges of radiation, I realize that it's not just about creating a place to live, about ensuring the survival of future generations. Colonizing another planet is not just about getting there. It's about building a society that can thrive for generations to come. And that means developing technologies and systems that will keep us safe, healthy, and sustainable for the long haul. Finally, one of the most important factors in colonizing another planet is ensuring that we have access to the resources necessary for long-term survival. On Earth, we take for granted that we can grow food, extract water, and mine materials from the ground. But on another planet, we would need to develop ways to mine local resources and recycle everything, from water to food to waste. One approach is terraforming, which is the process of altering a planet's environment to make it more Earth-like. This could involve releasing gases into the atmosphere to create a greenhouse effect or melting ice caps to release water. While terraforming remains a theoretical concept, it's an area of intense research. Some scientists believe that if we find the right conditions on an exoplanet, we may one day be able to alter its atmosphere to make it more suitable for human life. The idea of terraforming is something that I find both fascinating and deeply philosophical. The thought that we could shape a world to suit our needs is a powerful one, but it also raises questions about ethics and responsibility. Should we be altering another planet's environment, even if it means making it habitable for humans? This is a debate that will likely shape the future of interplanetary exploration and colonization. Colonizing another planet is one of the most exciting possibilities of space exploration. But it comes with significant challenges, from the vast distances between us and potentially habitable exoplanets, to the technological hurdles we would face in adapting to alien environments. There's still much work to be done. But humanity has always been a species of explorers and dreamers. And the desire to venture beyond our home planet is a deeply ingrained part of who we are. The road ahead is long, and it's likely that generations of humans will live and die without ever stepping foot on another world. But the groundwork is being laid, and the dream of colonizing another planet is becoming more realistic with each passing day. The question isn't if we can do it, it's when we'll do it. If you've been inspired by the possibilities of colonizing other worlds, stay tuned. In the next episode, we'll explore the search for extraterrestrial life, we alone in the universe. Or is someone or something out there? Don't forget to like, share, and subscribe for more in-depth explorations of space exploration and the future of humanity in the cosmos. For centuries, humans have looked up at the stars, pondering the question, are we alone? The night sky, a shimmering ocean of stars, invites us to dream of distant civilizations, unknown life forms, and perhaps the very answers to one of humanity's greatest existential questions: is there life beyond Earth? The search for extraterrestrial life has captivated scientists, philosophers, and dreamers for as long as we've been able to look up at the stars. But how do we find something that we've never seen? Something we may not even be able to recognize if we do find it. In this session, we'll explore the fascinating methods scientists are using to search for alien life. From searching for biosignatures on distant exoplanets to listening for signals from alien civilizations. Let's take a deep dive into one of the most thrilling quests in science: the search for extraterrestrial life. What will it take to find the evidence, and what does it mean for humanity if we do? The idea of finding life beyond Earth isn't just the stuff of science fiction. It's a serious scientific pursuit. The methods used to search for extraterrestrial life fall into several categories, depending on the type of life we're searching for. Searching for biosignature. A biosignature is any chemical or physical property that indicates the presence of life, past or present. The hunt for biosignatures in the atmospheres of exoplanets is one of the most promising areas of research. Why? Because certain gases, like oxygen, methane, and carbon dioxide, are commonly associated with life. On Earth, for example, oxygen is produced by plants and other organisms through photosynthesis, and methane is often a byproduct of microbial activity. One of the most promising tools for detecting biosignatures is the James Webb Space Telescope, JWST, which was launched in 2021. JWST is designed to study the atmospheres of exoplanets in unprecedented detail, looking for the molecular compositions that could indicate life. It's capable of analyzing the light that passes through an exoplanet's atmosphere, which will allow scientists to determine if any of these key gases are present. If scientists detect gases like oxygen or methane in the atmosphere of an exoplanet, it could be a major clue that life exists on that planet, or at least that it has in the past. The challenge is that we don't know exactly what other forms of life might look like. So we have to look for biosignatures that are similar to what we recognize on Earth. The search for biosignatures isn't limited to just Earth-like planets in the habitable zone. We also look for signs of life in extreme environments, planets with unusual atmospheric conditions or strange climates. For example, scientists are studying Venus and its atmosphere, which contains phosphine, a gas that, on Earth, is primarily produced by biological processes. The concept of biosignatures is fascinating because it opens up the possibility of life beyond what we currently understand. We've always associated life with the kind of biology we know on Earth. But what if life elsewhere takes forms we can't even imagine? The idea that we could someday detect signs of life on a distant world, whether it's microbial life or something more complex, feels like the beginning of a new chapter in human history. The potential discovery of biosignatures would not only change our understanding of biology, but also force us to rethink our place in the universe. Are we really the only intelligent beings in the cosmos? Or are we part of a much larger community of life forms scattered across the stars? Listening for alien signals, the SETI Program 1. Of the most iconic efforts to search for extraterrestrial life is the Search for Extraterrestrial Intelligence, SETI. SETI is a scientific program focused on detecting radio signals from alien civilizations. The idea behind SETI is simple. If there are advanced civilizations out there, they might be sending signals into space. Just as we do with our own radio and television broadcasts, SETI scientists have been listening for narrowband radio signals, which are often used by civilizations to communicate over long distances. These signals are different from the normal background radiation that comes from stars, galaxies, and other cosmic sources. Instead, SETI researchers are searching for patterns in radio wave signals that don't occur naturally and could be evidence of intelligent life trying to reach us. SETI has been searching for signals for over 60 years, using both ground-based radio telescopes and space-based platforms. Despite thousands of hours of listening, no confirmed signals from alien civilizations have been found. However, SETI scientists remain hopeful. After all, Earth is just one tiny dot in the vastness of space. The fact that we haven't detected a signal doesn't mean we're alone. It just means we haven't found the right signal yet. I've always found the idea of listening for alien signals to be incredibly romantic. The thought that somewhere, out in the darkness of space, there could be another civilization sending messages, waiting to be discovered, is something that fires up the imagination. It's like we're all tuned into the same frequency, and it's only a matter of time before we make contact. Or perhaps it's a humbling reminder that we might still be alone in this vast, incomprehensible universe. SETI's search is a mix of optimism and patience. And even though we haven't found definitive proof of alien life, the fact that scientists are out there looking and that we're listening, something that gives me hope for the future. The Drake equation. Estimating the odds of alien life, the search for extraterrestrial life isn't just about looking for signs of life. It's about calculating the odds that life exists elsewhere in the universe. Enter the Drake equation, a mathematical formula developed by astronomer Frank Drake in 1961. The equation estimates the number of active, communicative extraterrestrial civilizations in our galaxy, based on factors like the rate of star formation in the galaxy, the fraction of those stars that have planets, the fraction of those planets that are in the habitable zone, the number of planets that develop life, a fraction of those planets that develop intelligent life, the expected lifetime of civilizations capable of communicating. While the Drake equation can't give us a definitive answer, it helps guide our thinking about the potential for life in the universe. According to the equation, if the right conditions are met, if stars form planets in the right places, and if those planets develop life and intelligence, the chances for finding alien civilizations are very real. The equation is a starting point for the scientific community to frame the search for life. The real challenge is estimating the values for each factor, many of which we still don't know. For example, how likely is it that life develops on a planet? How common is intelligent life? How long do civilizations last? These are all variables that remain unknown and make the search for extraterrestrial life a continuing mystery. What I find so fascinating about the Drake equation is that it takes a scientific approach to one of the biggest philosophical questions humanity has ever asked. Are we alone in the universe? While we don't yet have the answers, the equation shows that we're not just hoping or guessing, we're trying to quantify the possibilities. It's like trying to calculate the odds of winning the biggest lottery ever. But this one could change everything we know about ourselves. The search for extraterrestrial life is one of the most profound scientific endeavors of our time. Whether we're looking for biosignatures in exoplanet atmospheres, listening for alien signals, or trying to calculate the odds of finding intelligent life, each approach offers a glimpse into the possibilities that lie beyond. While we haven't found definitive proof of alien life yet, the search is just beginning. With advanced technology like the James Webb Space Telescope and ongoing efforts like SETI, the future of extraterrestrial exploration looks promising. The question of whether we are alone in the universe is one that could be answered in our lifetimes. And if we do find life out there, it would change everything we know about biology, the universe, and our place within it. I think about the possibility of discovering extraterrestrial life every time I look up at the stars. It's easy to feel insignificant when you consider the vastness of the universe. But finding alien life would fundamentally change our understanding of everything. We wouldn't just be exploring space, we'd be exploring our place in the grand, cosmic community. If the idea of discovering alien life excites you, stay tuned. In our next episode, we'll explore the future of human space exploration, what it will take to leave Earth behind and venture to new worlds. Don't forget to like, share, and subscribe so you don't miss out on the next big step in the journey to understanding our universe. For centuries, humanity has gazed up at the stars, dreaming of a future where we could travel beyond Earth, where we could step foot on other worlds. That dream is no longer just fantasy. With every new advancement in space technology, we are getting closer to making the impossible possible. Could one day soon be the start of a new chapter in human history. A chapter where humans live and work on planets beyond our own. The future of human space exploration is both exhilarating and uncertain. From missions to the moon, to plans for Mars, to the possibility of reaching far-off exoplanets, we're on the verge of an era where space travel could become as common as air travel is today. But there's much work to be done before we can truly call the cosmos our home. Let's take a journey into the future of space exploration, where humanity's boldest dreams are taking shape. One of the biggest developments in human space exploration came with NASA's Artemis program, which aims to return humans to the moon by 2025. The Artemis program is not just about landing astronauts, on the moon. It's about building a sustainable presence there, one that will serve as a stepping stone for future missions to Mars and beyond. The ultimate goal of Artemis is to establish a permanent lunar base where astronauts can live and work, performing experiments, mining resources, and testing technologies that will be critical for future missions to other planets. The Artemis missions are particularly significant because they will be the first time humans set foot on the moon since the Apollo missions of the 1960s and 70s. The technology has improved dramatically since then, and this new era of lunar exploration will rely on advanced robotics, 3D printing, and sustainable habitats, all aimed at building a self-sustaining lunar colony. This is no longer just about exploring the moon. It's about setting up humanity for long-term exploration beyond Earth. One of the key elements of the Artemis program is the Lunar Gateway, which will serve as a space station orbiting the moon. The gateway will act as a staging point for future missions to the lunar surface, and eventually to Mars. It will also be an international effort, with NASA, ESA, JAXA, Japan's space agency, and CSA, Canada's space agency, working together to build this station. What excites me about the Artemis program is that it's more than just a return to the moon. It's a building block for humanity's future in space. By establishing a sustainable presence on the moon, we're setting the stage for Mars missions and beyond. The idea that we'll have humans living and working on the moon again within the next few years is thrilling. And it makes me wonder, what will our world look like when space travel is just a part of our everyday lives? While the moon is just a starting point, the next big destination for human space exploration is Mars. NASA has set its sights on Mars as the next step in human colonization. The goal is to send astronauts to Mars sometime in the 2030s and eventually establish a long-term human presence there. But this journey will be far more challenging than anything we've attempted before. Mars is a planet that shares many characteristics with Earth. It has seasons, polar ice caps, and a day length very similar to ours. However, Mars is also a harsh, unforgiving world. The atmosphere is over 95% carbon dioxide with little oxygen, and the surface temperature can drop to a chilling -125 degrees Celsius at night. Furthermore, Mars lacks a magnetic field, leaving its surface exposed to solar radiation, which presents a significant challenge for human settlers. In order to make Mars habitable, we will need to create artificial habitats that can protect us from the elements, provide us with breathable air, and allow us to grow food. We'll also need to find a way to generate water, as Mars doesn't have large bodies of liquid water. Scientists are currently exploring the potential of hydroponic farming, where crops are grown in a nutrient-rich solution without soil, and methods of extracting water from the Martian atmosphere or underground ice. Another challenge is the distance. Mars is about 225 million kilometers 140 million miles from Earth, making travel there a long and dangerous journey. It would take current spacecraft anywhere from 6 to 9 months to reach Mars, depending on the positioning of the planets. This means that astronauts would have to live in space for months at a time. Without the ability to return quickly to Earth, the journey itself would require advanced life support systems to keep astronauts alive, healthy, and mentally sound over such a long period of time. The idea of sending humans to Mars is something that has fascinated me for years. Mars is the next frontier for human exploration. And even though the challenges are immense, I can't help but feel that we're on the verge of something extraordinary. The prospect of astronauts standing on the surface of Mars, looking up at the distant Earth, is an image that will be etched into history. And while we may face setbacks, I believe the excitement and curiosity driving these missions will propel us forward. In addition to NASA's Mars plans, there's another player in the game, SpaceX, a private space company founded by entrepreneur Elon Musk. SpaceX has made incredible strides in space technology, with their Falcon 9 rockets and Dragon spacecraft proving to be reliable workhorses for missions to the International Space Station, ISS. But the company's boldest plan is to make life multiplanetary specifically. By sending humans to Mars, Musk's vision for Mars colonization centers around the Starship rocket, which is designed to carry 100 or more people to the Red Planet at a time. The Starship is not just a spacecraft, it's a fully reusable, interplanetary spaceship designed to transport humans and cargo to Mars and beyond. SpaceX has already conducted multiple test flights of Starship, and while there have been some failures, the company is making rapid progress. Musk's vision is clear. He believes that the future of humanity lies in becoming a multiplanetary species, and Mars is the first step toward that goal. SpaceX is working on developing the necessary technology to not only transport people to Mars, but to make life there sustainable. This includes building habitats, mining resources, and eventually creating a self-sustaining colony. The idea of SpaceX making interplanetary travel a reality is, to me, incredibly exciting. Elon Musk has always been a visionary, and his ambition to establish a human colony on Mars feels like the first real step toward making multiplanetary living a reality. It's not just about sending humans to Mars, it's about building a future for humanity on another planet, one where we can thrive and grow. The fact that this is all happening in our lifetimes is mind-blowing. Beyond Mars, the future of human space exploration could lead us to even more distant worlds, exoplanets in the habitable zone of other stars. But traveling to these worlds is no small feat, even if we develop faster spacecraft capable of traveling to nearby stars. We're still talking about distances measured in light years. The nearest potentially habitable star, Proxima Centauri, is over 4 light-years away. It would take our current spacecraft thousands of years to get there. To make interstellar travel a reality, we need to develop breakthrough propulsion technologies. One idea being researched is nuclear fusion, which could provide the necessary speed to travel to other stars in a human lifetime. Another concept is solar sails, which use the pressure of sunlight to propel spacecraft to incredible speeds. These ideas are still in the early stages, but they represent the kind of out-of-a-box thinking that will be necessary to make interstellar travel possible. The thought of traveling to other stars is truly mind-boggling. Right now, it seems almost impossible. But when you think about the progress we've made in space technology in just the last few decades, it becomes clear that the future of space travel is full of possibility. It might take hundreds or even thousands of years to reach other stars. But I believe that the spirit of exploration will drive us to overcome those challenges. The future of human space exploration is an exciting and challenging frontier. From returning to the moon with Artemis, to landing on Mars with NASA and SpaceX, to dreaming of traveling to distant exoplanets, humanity's journey beyond Earth is just beginning. But for all the excitement, the road ahead is filled with challenges: distance, technology, sustainability, and survival, as we prepare to take the next steps in our space exploration efforts. We're reminded that the pursuit of knowledge and adventure is a deeply human trait. The dreams of tomorrow might feel far off, but the work being done today is shaping the future of humanity in space. I can't help but feel optimistic about the future of space exploration. While there's a lot of work to be done, the potential is limitless. We're on the verge of something groundbreaking, and the possibility of humans becoming a multiplanetary species is something that will redefine the course of history. If you're excited about the future of space, exploration, and the possibility of humans living beyond Earth, make sure to subscribe, like, and share. In our next episode, we'll dive into the search for extraterrestrial life and what it would mean for humanity to find life beyond Earth. The journey has just begun, and there's so much more to discover. So much more to discover. We've come a long way since the first exoplanet was discovered in 1992. Today, we know that planets orbit stars throughout the universe, and many of these planets could be similar to Earth. Some even lie in their stars' habitable zones, where conditions might be just right for liquid water to exist. But there's one question that remains: are we alone? The search for life beyond Earth is one of the most profound quests in science. Whether we're searching for microbial life on Mars, looking for signs of alien civilizations in distant stars, or studying the atmospheres of far-off exoplanets for biosignatures, humanity is trying to answer one of the biggest questions we've ever asked: is there life out there? In this session, we'll look at how far we've come in the search for extraterrestrial life and what the future holds. Could we discover microbial life on Mars or make contact with an alien civilization? What would it mean for us if we found life beyond Earth? And how would it change our understanding of the universe and our place within it? The search for life beyond Earth is nothing new. For decades, scientists have wondered if we are the only ones in the universe, or if there are other forms of life out there. But only recently have we begun to have the tools to answer this question. The discoveries of exoplanets, especially those in the habitable zone of their stars, have brought us closer to answering this question. One of the most promising areas of research is the search for biosignatures, indicators of life, such as gases like oxygen, methane, and carbon dioxide in the atmosphere of exoplanets. These gases on Earth are produced by living organisms. If we detect these gases in the atmosphere of an exoplanet, it could be a sign that life exists or once existed. There, the James Webb Space Telescope, JWST, launched in 2021, is expected to be a game-changer in this quest. Its infrared capabilities allow it to study the atmospheres of distant exoplanets in unprecedented detail. By analyzing the light that passes through an exoplanet's atmosphere, JWST will be able to detect the presence of potential biosignatures, helping scientists determine whether life is possible or even already present. On these distant worlds, the idea that we might find life beyond Earth is, to me, one of the most exciting possibilities for the future of science. It would fundamentally change everything we know about biology, the nature of life, and even our place in the universe. Finding life elsewhere, even in its simplest form, would demonstrate that life isn't just a fluke of Earth, could be a widespread phenomenon throughout the cosmos. And if we find intelligent life, well, that would be a whole other revolution. But even more than the scientific implications, the idea of finding life beyond Earth feels deeply human. It's a reflection of our curiosity, our desire to understand the world around us, and the need to know if we're alone in the vastness of space. But biosignatures aren't the only way to search for life. The SETI search for extraterrestrial intelligence. program has been searching for signs of intelligent life for over 6 decades. The idea behind SETI is simple. If alien civilizations are out there, they might be sending signals, much like we do with our own radio and television broadcasts. By listening for radio signals from other civilizations, SETI hopes to detect something that is artificial, a sign that we're not the only intelligent species in the universe. SETI scientists primarily listen for narrow-band radio signals, which are very different from the natural background radiation that comes from stars, galaxies, and other cosmic sources. While no definitive signals have been found yet, the program continues to scan the sky for signs of intelligent life. SETI uses some of the most advanced radio telescopes in the world, like the Allen Telescope Array and the Arecibo Observatory, to scan the cosmos. Despite not having found anything definitive, SETI scientists remain hopeful, and the search for alien signals continues. The fact that we haven't found anything doesn't mean we're alone. It just means we haven't found the right signal yet. Listening for alien signals with SET always fascinates me. The thought that somewhere out there, an alien civilization might be trying to contact us sends shivers down my spine. Even though we haven't found anything yet, it's comforting to know that we're actively searching. The idea that we might one day hear a message from an advanced civilization is something I can't help but imagine. It's almost like a cosmic waiting game, where the stakes are incredibly high. Beyond listening for signals, we're also looking for evidence of alien life in our own solar system. Mars, with its cold, dry surface and history of liquid water, has long been a focus for the search for life. NASA's Perseverance rover, which landed on Mars in 2021, is exploring the planet's surface for signs of ancient microbial life. The rover is searching for biosignatures, chemical markers that could indicate the presence of life in the planet's past. One of the most exciting aspects of the Perseverance mission is its goal of collecting Martian soil samples and returning them to Earth for analysis. This could be the first time we've brought samples from another planet back to our laboratories for detailed study. If we find any evidence of life in those samples, it would be a monumental discovery. Mars isn't the only target, though. Other moons in our solar system, like Europa, one of Jupiter's moons, also hold great promise for the search for life. Europa is thought to have a subsurface ocean beneath its icy crust, and scientists believe that this ocean could harbor microbial life. In the coming years, NASA's Europa Clipper mission will study Europa in greater detail, looking for signs of life beneath its surface. The search for life in our own solar system feels incredibly personal to me. Mars has been a target for human exploration for so long, and every new discovery makes me wonder if we're on the edge of finding something incredible. Whether it's ancient microbial life in Mars's soil or living organisms in the subsurface oceans of Europa, the fact that we're actively exploring the possibility of life right in our own cosmic backyard feels deeply significant. It's like we're on the cusp of an unprecedented discovery, and we're living through it. The search for extraterrestrial life is one of the most profound endeavors of our time. Whether we're looking for biosignatures on distant exoplanets, listening for alien signals, or searching for life in our own solar system, each approach brings us one step closer to understanding if we are truly alone in the universe. If we do find life, even in its simplest form, it would change everything we know about biology, about the universe, and about ourselves. And if we find intelligent life, the possibilities are endless. It could open up a new era in human history, one where we are no longer just observers of the universe, but active participants in a cosmic community. For now, the search continues. As technology improves and new missions are launched, we're getting closer to answering one of humanity's oldest questions. Are we alone? I can't help but feel a deep sense of anticipation as we continue searching. I think about the moment when we might finally find evidence of life beyond Earth and how it will change everything we know. But even if we don't find life in the immediate future, the pursuit of this question is what makes us human. It's about exploring the unknown, questioning the impossible, and pushing the boundaries of what we think is possible. The search for exoplanets and alien life has already brought us closer to answering one of humanity's most profound questions. Are we alone in the universe? As technology advances and our understanding of distant worlds deepens, we may one day find a planet that is not only habitable, but could offer us a second chance at life beyond Earth. But even if we don't find another Earth, the journey is invaluable. The search for life forces us to re-examine what makes Earth so special and to appreciate the fragility of our own existence. So, what comes next? The James Webb Space Telescope, which launched in 2021, is set to study exoplanets in even greater detail, potentially uncovering signs of life we never thought possible. In the coming decades, space agencies like NASA and private companies like SpaceX will continue to push the boundaries of what we know about space. And the dream of living beyond Earth may not be as distant as it seems. Join us as we continue to explore the mysteries of the cosmos. Don't forget to like, share, and subscribe to stay updated on the latest in space exploration and the search for extraterrestrial life. What do you think? Could we one day live on another planet, or will Earth remain our one and only home? Share your thoughts in the comments below.